Let's keep discussing different types of angle relationships. A transversal is a line that intersects two or more lines. So in this picture, T is the transversal to lines L and M. When a transversal intersects two lines, there are several angles formed. There are angles that we talked about in previous days, like angle 1 and 3, which are vertical angles. There's also linear pair, like angle 1 and 2, but there's also these four new types of angles. So corresponding angles are angles that are the same side of the transversal and in the same position. So they're both on the top left. They're both on the top right. Bottom left, bottom right. So in this picture, angle 1 and angle 5 are corresponding angles. Likewise, angle 2 and angle 6, angle 3 and angle 7, and then angle 4 and angle 8. If you have two lines and a transversal, there will always be four pair of corresponding angles. One of them will be on the outside of the parallel lines and one of them will be on the inside. So in our next three types of angles, you'll see the word either interior or exterior. So the interior refers to in between the parallel lines. So right here, I'm just going to abbreviate because I don't have space. And then the exterior would be anything outside of those two lines. So that's exterior, and this is exterior. So 1, 2, 7, and 8 fall on the exterior, and then 3, 4, 5, and 6 fall on the interior. There's also alternate and same side. So use that same picture. When they're on the same side of the transversal, that would be something like 1, 4, 5, and 8. They fall on the same side. Likewise, 2, 3, 6, 7. Those are all on the same side of the transversal. Alternate means they're on opposite sides of the transversal, like 2 and 8 or 3 and 5. So when we put those words together, alternate means different sides of the transversal. Inside means in between the parallel lines. There are going to be two pair of alternate interior angles, and in this particular picture, that would be angle 3 and angle 5, and angle 4 and angle 6. Different sides of the transversal, but in between the two lines. Alternate exterior are still on different sides of the transversal, but they're outside of the parallel line. So in this picture, angle 1 and angle 7 are alternate exterior angles, and angle 2 and angle 8 are alternate exterior angles. Same side interior angles are also known as consecutive interior angles. So they're on the same side of the line of the transversal, but they're in between the two lines. So in this particular picture, that would be angle 4 and angle 5. That would be a pair of same side or consecutive interior angles, and then your other pair would be angle 3 and angle 6. So for this example, all I want you guys to do is to be able to identify the angle relationship. And if it's none of the ones discussed, you can write none. So angle 1 and angle 8. Those angles fall outside of the lines, so they're exterior, and they are on opposite sides of transversal R. So those are alternate exterior angles, and I'm just going to abbreviate here for sake of space. And I'm going to do the angle symbol with an S. That means angles. Okay, now we're looking at angle 2 and angle 3. 2 and 3 are in between the two lines, so that's interior, and they are on the same side of transversal R, so these would be same side interior angles or consecutive interior angles. I'm just going to write same side interior angles. Right, now let's take a look at angle 5 and angle 7. Angle 5 and angle 7, one is on the exterior, one is on the interior, and they fall in the same position. They are both bottom left in this picture, so that makes them corresponding angles. All right, now we're looking at 2 and 7. 2 and 7 are in between the two lines P and Q, and they are on opposite sides of transversal R, so those are alternate interior angles. One and 3. Here's 1, here's 3. So 1 is on the exterior, 3 is on the interior. They are both top left, so these would be corresponding angles. And then finally, angle 6 and 7. Angles 6 and 7 are both on the inside of lines P and Q, and they fall on the same side as of transversal R. So that makes them same side or consecutive interior angles. Whatever word you like, you do need to be familiar with both because you don't know what you're going to see when you take your test. All right, now so far we've just worked on being able to identify the names of the angles, but if the lines are parallel, then there is going to be important stuff about those angles. So your corresponding angles are going to be congruent. So like angle 1 and 5 are congruent, angle 2 and 6 are congruent, angle 3 and 7, and angle 4 and 8. Alternate interior angles will also be congruent. Angle 3 and angle 5 would be congruent, angle 4 and angle 6 would be congruent. Alternate exterior angles, also congruent, 1 and 7, 2 and 8. Your same side or your consecutive interior angles are going to be supplementary. Remember that supplementary means that they add to equal 180. The sum is 180. So 4 and 5 would add to equal 180, and so would 3 and 6. Within this picture, and I mentioned this at the beginning, we still have linear pairs, and linear pairs are always supplementary. So angle 1 and angle 2 and 3, 3 and 4, 1 and 4. Those are all examples of linear pair, and likewise at the bottom, 5, 6, 6, 7, 7, 8, 5, 8, all linear pair because pair means two and linear means line, two angles that make a line. And then you have vertical angles also in this picture, and those will always be congruent. 1 and 3, 2 and 4, 5 and 7, 6 and 8. Those are the angles opposite one another. In order to know that two lines are parallel, you're looking for one of two things. So you might see these little arrows right there. That means that they're parallel. Or you also might be given something like, I'm just going to name these real quick, just call them L and M. You might see L is parallel to M. So this is your parallel symbol right here. Just kind of looks like two parallel lines. You don't want to assume lines are parallel. All right, so let's look at a couple examples with parallel lines and angle measures so we can try to find some missing information. So for this example, we're told that the lines are parallel. We know that because of the little arrows on them. And make sure you're looking at these arrows right here, not the arrows on the end of the line. It's not technically the end, but visually it looks like the end. We are told that angle 6, the measure of angle 6 is 142. So I am visual. I like to write it within the picture, and then I'll also write it within the table. So there are a lot of different ways that you can go with this. So I'm going to start with what you've spent more time on. So angle 1 and 6. are going to be congruent because they are vertical angles. So I know the measure of angle 1 is 142 degrees. 1 and 5, 5 and 6, 2 and 6, or 1 and 2 are all linear pair. That means that they add to equal 180. So to find angle 5, I'm going to do 180 minus 142. And that will give me both 5 and angle 2 measures. Since they're vertical angles, they're also going to be congruent, and that's going to be 38 degrees. So 2 and 5. And again, there's a lot of other reasons that you could give those measures, but I just wanted to go based on what you've spent more time on. You have done practice with vertical angles and you've practiced with linear pair. So now we need to use our new angles. So the measure of angle 3 is going to be equivalent to 1 because they are corresponding angles. So that means the measure of angle 3 will also be 142. Instead of using corresponding angles, you could have used alternate interior angles. Alternate interior angles are 3 and 6, and they're congruent. So 6 is 142, then 3 has to be 142. For 7, you could use a linear pair to angle 3. You could use a corresponding angle with angle 5. You could use an alternate interior angle with angle 2, or you could use a same side interior angle with angle 6. However you look at it, you're going to find that the measure of angle 7 will be 38 degrees. So again, 3 and 7 have to add to equal 180. I'm sorry, not 3. Yeah, 3 and 7 have to add to equal 180. 6 and 7 have to add to equal 180. 5 and 7 have to be congruent, and 2 and 7 have to be congruent. And whichever way you want to look at it, it works that way. So to find 4 is going to be 38 as well. Here's why. A lot of different reasons. Angle 4 is a vertical angle to angle 7, so they should be congruent. Angle 4 is a linear pair with angle 3, so they should be supplementary. Angle 4 is a corresponding angle with angle 2. They should be congruent. Or angle 4 is an alternate exterior angle with angle 5, and they should be congruent. Finally, for the measure of angle 8, it will also be 142, and we have all the reasons for this. So angle 8 and angle 3 are vertical angles, so they should be congruent. 8 is a linear pair with 7 or 4, so they should be supplementary. 8 is corresponding with 6, they should be congruent, or 8 is an alternate exterior with angle 1, and they should also be congruent. So lots of different reasons to find these measures. I just want to keep re-emphasizing that vocabulary. That's why I'm explaining all the different ways that you could come up with the angles. All right. For the last example, we are told to find the value of x and y. And we know that the two lines are parallel because it says L is parallel to M in the instructions. So I'm going to start with X. Sometimes you don't start with X. Sometimes you have to find Y, but I'm just going to look at the X's. So I have an X right here, 9X plus 25, and then I have a 13X minus 3. And I want to go through all my angle relationships and see if they fit one of those pairs. So they do. They're both in the same position in regards to the line, the transversal. They're top left. One's outside, one's inside, but they're both top left. That makes these corresponding angles, and corresponding angles are congruent. So that means that to solve this, I'm going to do 13x minus 19 equals 9x plus 25. I'm going to add 19 to both sides, subtract 9x from both sides. Combine like terms, that gives me 4x equals, what, 44. Divide both sides by 4, and that gives me x equals 11. All right, so got x. Now we need to find y. So if I compare the 17y plus 5 to the 9x plus 25, they have no special angle relationship. They're not one of the types of angles that we've discussed. But the 13x minus 19 and the 17y plus 5 are a linear pair. That means if I add them up, they should equal 180. The only problem with doing it with the way it is now is that I would have both x and y. But I found the measure of x, so what I'm going to do is I'm going to substitute x, which is 11, into that 13x minus 19. So I'm going to do 13 times 11, which is 143, and then I'm going to subtract 19. So just so you can kind of see, I'm going to do 13 times 11 minus 19, and that's going to give me 124 degrees. Which means that the other angle, the 17y plus 5, again, those two angles have to add to equal 180. So if I do 180 minus 124, that gives me 56 degrees. So that means this angle should be 56 degrees. And again, I got that by doing 180 minus 124. So I'm going to set the 17y plus 5 equal to 56, and I'm going to solve that. So I'm going to subtract 5. That gives me 51. Divide by 17. That gives me y equals 3. And you can always plug back in and make sure that that equals 56. It will. And you could have also on this one, if you didn't want to set it directly equal to 56, you could have done 17y plus 5 plus 124 equals 180, and that would have given you the exact same thing. So make sure you're going through your angle relationships. You know how to identify the angles, and you know what's true of those angles when they are parallel.